We're here in Visual Studio. I've got some simple C code. It's set up, the project is set up to work with the Altia API, just a couple project setting changes. Of course, we include altia.h. But really what I want to talk about is how you make Altia events come into C code from the API and then go back to Altia graphics via the API. So we're going to be concerned with this video is two events, speed and audio button press. And we're going to affect those via C code and the API. So real quick, I'm just going to create objects that can be used for those events in Altia Design, and I'm going to go real quick for this because some of the previous videos covered this in more detail, but I think it's good to kind of tie together where things work and how they're actually talking to each other via the API if you sort of see it as we go. This audio button press is going to be the result of the card switch for this button. Okay, so I'm just going to take these two images and fill this deck with it. We've got an upstate downstate image on this deck. This deck now has the capacity to change cards there. I'm going to name this. This is our signal audio button press. This that animation name. So the deck card is going to change like that when it gets a changed. Well, I'm sorry, I should say when Altia sends this out to C code, it's going to affect speed. So let's make it so we don't have to manually change that. Let's just do left down on the whole audio. There it is. I can down tab. Okay, and then a left up event. Whole object. I want a rectangular. And again, not many words here, just a quick recap so you guys can see how things connect. If you want full instruction on these things, make sure to watch the previous videos on animation, stimulus, and the deck object. Alright, so we've got a left down, left up, and now if we go to run mode, we've got a working button. We now have the capacity, if we watch the animation editor, to quickly change the value of audio button press. But we don't have speed yet, right? So that's where the needle comes in. Let's go ahead and grab that, and I'll just close this here. Oops, can't drag things around in run mode, gotta be in edit mode, there we go. Doesn't have to be perfect. We'll animate this, we'll call this speed, and tab. Actually, I don't want to define quite yet without rotating it first. There we go, that looks good. Rotate it around. Alright, that's the last step to set up the model to respond to that code. And I just wanted to do this so you guys get a real idea. Okay, what is the API code powering? Well, our animation called speed is what I just built. Our animation called audio button press is the deck card animation that we're now, triggering with this stimulus 010. So if we come back now and we look at our code, we're basically registering a callback against audio button press. What that means is I want to listen for audio button press. If I get a value of audio button press, go ahead and call this callback function. Within that, if the value is 1 from 0 to 280, send to Altia the value of speed. So it's going to increase from 0 to 280, basically min to max. And then if it's not 1, or if it's 0, that is audio button press equals 0, decrease speed from 280 to 0. Now I think if I hit F7, it's just going to say, up to date. Yeah, I've got that. So let's go find that on my disk and run it as a client. Now before I do this, I just want to say that if you're a developer on a larger source project, you would actually go ahead and link together your final code for your hardware. You'd link your external code with the Altia code, graphics code, and put it on the device, possibly as a single binary. But what I'm doing is showing you the API, which does not change. So the communication from your C code to Altia will always look similar to this with AT add callback or maybe AT select event. There's a couple different methods you can communicate with the API, which are documented. But in this case, we're using a callback function. But when you send events to Altia Design or listening from, that's not going to change. It just might be in a larger, more complicated source file. For the sake of this video, I wanted something quick and easy. Okay, but here's the difference. I compiled this as a executable, Win32 executable, and I'm now able to run this via Start Client against my active Altia Design session. That's really cool, and the reason is if I click refresh, you can see it's connected on port 5100. The reason is this. If I go into run mode, well, first let me edit objects just to show you we're in an active Altia design session. If I go into run mode, there's that API talking to real Altia objects in real time, so I can move objects around and go back into run mode, or even, you know, make it look really ugly and take that needle. Whoops, focused in one too far. Take that needle, put it over there. This is just real Altia objects during an active session. But the beauty here, what's happening, is that the C code is responding to the animation events in real time during active editing because I'm connected to the executable of this code. So the API is running against an active session of Altia Design, which allows me to verify two things. I can verify that, yep, my animation looks correct. Let me put this somewhere back where it looks okay, and send it back. And there we go, that looks alright. So I can verify two things. I can click it and verify that animations look correct, but also because it is moving when I click it, I'm also verifying my logic is correct, all in real time. So in 6 minutes, I built a button, I built a rotating needle, I connected that to some external C code via the API, and then during that same active session, I was able to test my newly built objects, animations, and external logic via the API.